Let's take a look at multi-digit multiplication using base 10 blocks and building arrays. We're going to take a look at the problem 12 times 14. We're going to model that by building an array. So I want to start with decomposing the numbers into 10 and 2. 10 and 2, 10 plus 2 is 12, and 10 and 4, 10 and 4 is 14. And I'm going to do this just for some organization here. Right. And now I want to go ahead and build my array. I need 10 groups of 10. Groups of 10. All right, and I'm actually going to erase this and bring it down just a little bit. All right, I have 10 groups of 10, and now I also need 2 more groups of 10, and I'm going to bring those down here for a little bit so we can see. There's the 10 groups of 10. Now we have 2 groups of 10, and now I need 10 groups of 4. And I also need 2 groups of 4. All right, so let's look at what we have here. So we have a 10 times 10, 10 by 10, and we have a 10 by 4, 10 times 4. And then here we have a 2 by 10 and a 2 by 4. And I'm actually going to go ahead now and move this up. I'm going to try to capture that. Oops, that did not work. All right, I'm going to go ahead and capture this by just highlighting the whole thing. I wanted you to see how I had broken those numbers apart. But now I want to make one array out of the whole thing and move it all up here together. All right, so let's see what we have here now. I'm going to use my pen because I still want to show you where that space is between those two. So I'm going to use this to draw that out so we can real clearly see what we have here. Now, right here, we have a 10 by 10. 10 times 10 is 100. And then a 10 by 4, 10 times 4 is 40. And if we were to count these, there would be exactly 100 square units here and exactly 40 square units here. Let's come down here. 2 times 10, 2 groups of 10 is 20. And then 2 groups of 4 is equal to 8. And to get the total area, we're going to add 100 plus 40 plus 20 plus 8, which is 168. There's a one-to-one correlation here. There are exactly 168 square units in this array if you were to count them all up. So what we're going to look at next will be how to use an area model without the grid, but just drawing proportionally the model to those numbers, and how that would be a bit of a transition for students from what would be a more concrete representation to what would be more of a representational method. Let's take a look at 12 times 14 using an area model. When we work with area models on a blank page, we just need to be conscientious about the spaces that we're drawing. As best we can, they should be proportional to their values. So for example, 10 by 10, when I draw this out, this should be as close to a square as I can freehand. And then my 2 should obviously be significantly smaller than my 10. And then my 4 will be about double the size of my 2. And then I've got a little piece here I want to erase. So, okay, that's pretty close. So 10 plus 2 is 12, and 10 plus 4 is 14. So what's happening in our area model? Well, 10 times 10. 10 times 10, I'm going to go ahead and we can use this space. This is what a lot of times our students will do. 10 times 10 is 100. And if we were doing this on grid paper or with an array, we can actually count 100 squares. But we're moving one step away from the arrays to a little bit more of a representation and less of a concrete model. So we have our 10 by 10, which is 100. And then 10 times 4 is 40. 2 times 10, just 20. And 2 times 4 is 8. And when we add these together, we have 100 plus 40 plus 20 plus 8, which is 168. Now I'd like us to take a look at the area model right next to the partial products. When working in partial products, I'm going to start with the 14 and with the digit in the ones place, and I'm going to multiply it by the digit in the ones place of my 12. So in this case, 4 times 2 is 8, and I'm going to keep track over here. Next, I'm going to go 4 times 10. 4 times 10 is 40. Then I'm going to move to the tens place with my number 14. 10 times 2 is 20. And then 10 times 10 is 100. Let's go ahead and add these up. Now what I'd like for us to do is to look at how we can make connections between these two strategies. We have a lot of students potentially using the area model strategy, and a lot of students are potentially using the partial product strategy. It's a little bit more efficient, may take a little bit less time for some students. Let's see if we can find some of this work here also appearing in the area model. So this 8, this 4 groups of 2, where do you see 8? Well, there's 8 here. Now I laid my numbers out differently, so I wrote that as 2 times 4. Here it's written as 4 times 2 with the commutative property of multiplication. Those are equivalent, and they both have a product of 8. Let's next see if we can find the 40. 40, 4 times 10 over here is 40. 10 times 4, commutative property of multiplication, equivalent, and they both have a product of 40. How about the 20? Here's 20. 2 times 10 is 20. 10 times 2 is 20. And 100. There's our 100. 10 times 10 is 100. 10 times 10 is 100. So we can help students make connections between those two strategies. All right, what I'd like for us to do now is go ahead and use the traditional standard algorithm, and we're going to compare that to the partial products work. 4 times 2 is 8. 4 times the 1 in the tens place is 40. Let me put my 4 here. Moving to the tens place in my 14. 10 times 2 is 20. And 10 times 10 is 100. All right, now let's see if we can make some connections. This 48, where does this come from? If we're comparing student work, and we have some students using the traditional standard algorithm, and some students who've maybe transitioned from area model to a partial products notation, where does that 48 show up here? Well, what's 8 plus 40? 8 plus 40 is 48, isn't it? 120. Where's the 120 in the partial products? 20 plus 100 is 120. And then we both have the same answer. 12 times 14 is 168. So we can help students move from the area model to a partial products notation to a traditional algorithm, making connections along the way.